Okay, before I get to the Wingate protocol, I want to talk about energy systems a little bit. I hope that this is somewhat familiar to you from exercise physiology. If it's not, hopefully it's a good reminder, or just all new information. But hopefully you can get a basic understanding of energy systems here, that will help you throughout the course. So, I want to orient you to this figure here, which I think is a wonderful display of kind of how our energy systems work together to fuel our activity. So we know that ATP is our primary fuel source of activity and muscle contraction. So when we first start activity, we use ATP stores to fuel that first burst of activity. And you'll see the exercise intensity here decreases as time goes on because we can't sustain super high exercise intensity for very long. So we have this high exercise intensity right from the get-go. To fuel that, we can dig into these very small but efficient ATP stores. So it's readily available energy. That burns out in about 2 seconds, but that gives us just enough time to ramp up other energy systems. So as ATP stores run out, we can start to use the ATP PCR system. So we have phosphocreatine that is transformed or changed into ATP. It's fast, but it only gives us 1-to-1. So 1 PCR to 1 ATP, not that efficient. So that burns out pretty quickly as well, at about 10 seconds of exercise at a high intensity. And then we have anaerobic glycolysis that starts to take over. So this is the beginning stages of glycolysis before oxygen is required. So at the kind of end of this first stage of glycolysis, you either produce lactic acid or pyruvate. If oxygen's available, you get pyruvate and go on to aerobic metabolism. If oxygen's not available, we start to build up lactic acid. So in this short-term period, oxygen's probably not available. So we're using a lot of energy from anaerobic glycolysis, but also building up lactic acid, which will make us fatigued. So that sustains activity for about a minute. But that's just enough to probably get you through whatever anaerobic bout of exercise you're doing, because it's usually in these high intensity, short duration activities. So that's very basic understanding of anaerobic metabolism and how we get energy without oxygen. So now we can get into the Wingate test, which is a test related to our anaerobic metabolism. So we have the Monarch bike, which can be used for a lot of different things, anaerobic, aerobic, all of these different tests. But we specifically will be going over the Wingate test in this class as a measure of anaerobic capacity. So the Wingate test is a 30-second all-out bout that you'll learn about in class, where you pedal as fast as you can against a certain percentage of your body weight for 30 seconds straight. By the end, you're likely crawling through mud, trying to keep pedaling because it is a pretty high percentage of your body weight. So the 30 seconds is usually as much as someone can sustain. So by doing this test, we're able to get a great picture of someone's anaerobic power. And this is important because an athlete's ability to quickly utilize and produce energy is a huge determinant of how they'll perform in sports that require these quick bursts of speed at high intensities. So think track and field runners, hockey players, where this quick burst of energy is needed to perform well in the sport. So if someone does well on the Wingate, they're probably better at sports like that. So this is a test of your anaerobic energy systems. Remember before I said that these burn out at about a minute to 30 seconds. So you're really using up all of those anaerobic energy systems during this test. So ATP PCR, ATP stores, and fast glycolysis fuel this before you have enough time to get oxygen to the muscles. So by doing the Wingate test, you can get a lot of different outcome measures. One is anaerobic power, or the work per unit of time during this short effort. So this is reflective of the capacity of this individual to use intramuscular ATP and PCR in anaerobic glycolysis. So their power is reflective of their anaerobic capacity. You can also look at someone's peak power, or the maximum amount of power that they output during this test. That is generally the first 5 seconds of the test before they start to get fatigued. So To calculate peak power, you use the number of revolutions of the pedals completed in the first 5 seconds of the test, or the maximum amount of power that they output during that test. So then the most commonly used measure is average power. This uses the number of revolutions completed during the full 30 seconds multiplied by the resistance they had on the flywheel. So this is subjective to the individual and their body weight and how much weight was added to the Wingate test, and then how many revolutions the pedals completed during that time. So that would be of someone's average power. So in general, the Wingate test is testing your anaerobic energy systems to see what kind of power output you can accomplish, which is reflective of how efficient these anaerobic systems are, and how much power you're able to produce, which is very important for athletes who perform these types of tasks in their sport.